Hello everybody, how are you? Welcome to my channel Math Insights. Today we are going to discuss some more laws on sets. Before going to that, we have to discuss very important law. Basing on that, we will discuss more results on sets. Shall we? In the previous videos, we discussed what are meant by equal sets. When two sets will become equal, that is most important in set theory. See, equality of two sets is possible when the first set is subset or equals to second set and second set is subset or equals to first set. If you take two sets A and B, and if A is subset or equals to B and B is subset or equals to A, then automatically the first set A will become equal to second set. Say I am writing A is subset or equal to B. That means when A is subset to B and B is subset to A, then A will become to equal B. And also when A is equals to B, automatically the set A will become equals to B. So you may write that result. See, A is subset or equals to B and B is subset or equals to A. This is called double implies. Means if this condition is satisfied, then this is a result, and if this condition is satisfied, then this results. That means if you have this result, you may say that A is equals to B, and if you have A is equals to B, then you may say that A is subset or equals to B and B is subset or equals to A. Depending on this, we will solve more results. In the previous video, we have gone through some results based on set theory. Now there are more results. We will discuss that results and we will solve basing on this equality of two sets. In the previous video, we learnt main results on sets. Those laws are idempotent laws, commutative laws, distributive laws, associative laws, De Morgan laws. Those are main laws. Along with those main laws, we have some more important results on operations of sets. A minus B is equals to A intersection B dash. A minus B, B is equals to pi, where pi is a null set. A minus B is equals to B dash minus A dash. A is subset or equals to B, then that is implies that B dash is subset or equals to A dash. And A union B may be written as A minus B union B minus A union A intersection B. A minus B is equals to A intersection B. And if you see the seventh one, A minus B is equals to B minus A, suppose, then automatically the set A will be equal to set B. If A union B is equals to A intersection B, automatically the set A will become equals to set B. In this way, you may have these additional results. Now I want to prove A minus B is equals to A intersection B dash, and we just learnt how to prove two sets, how to prove the equality of two sets. If first set is subset or equals to second set and second set is subset or equals to first set, automatically the first set will become equals to second set. Basing on those law of equality of sets, we will prove all these results. For our convenience, I will prove the first two or three, then you may take these results as your homework to prove. If you take the first result, that is A minus B is equals to A intersection B dash. See here, this will become the first set, that is A minus B, and this will become second set. As per the equality of two sets, you have to prove the first set is subset or equals to second set, and then second set is also subset or equals to first set. Then automatically, basing on the equality of law of equality of two sets, the first set will become equals to second set. Now you have two methods to prove the equality of two sets. The first one is set builder form. This is the most method used by most students, and second one is by assuming the elements in the sets. You may prove that first set is equals to second set. Now I will prove basing on set builder form, then you may try basing on assuming the elements. See, I am taking first set, that is a minus b. I will assume an element x in a minus b, and I will prove that the same element is also in the second set. Then the first set will become subset or equals to second set. Let x belongs to a minus b. This x is an element which is in a minus b, belongs to. That means if it is in a minus b, that means it is only in a and not in b. Therefore that may be written as x belongs to a and x does not belongs to b. Minus means you are removing, that means you are not taking the elements of b. Therefore this may be written as x belongs to a, and if x is not in b, then it will be in b dash. B and b dash are disjoint sets. That means whatever the elements in b, those elements will not be in b dash. Therefore if x is in b, therefore it will, if x is not in b, automatically it will be in b dash. See, x is in a and b dash. That means it is in the intersection of two sets a and b dash. Therefore I will write x belongs to a intersection b dash. That means I have taken the element x in a minus b, and I am proving that the same element is also in a intersection b dash. Therefore as per the rule of subset, if the element is in first set and it's also in second set, then first set is subset or equals to second set. Therefore a minus b is subset or equals to a intersection b dash. Let assume this as equation 1. Similarly, I will take one element in the second set and prove that the element is in also in the first set. Let x belongs to a intersection b dash. That means if it is in intersection of two sets, it will be in both sets. That means x belongs to a and x belongs to b dash. That implies to x belongs to a and if x is in b dash, it will not be in b. Therefore x does not belongs to b. Therefore x belongs to a minus b. That means element x is in a and not in b. That means not means you are removing that. Therefore I am writing minus. I have taken x in a intersection b dash, and I am proving that the same element is in a minus b. Therefore the first set a intersection b dash is subset or equals to a minus b. Then you may assume this as equation number 2. If you see the first equation and second equation, as per the law of equality of two sets, if first set is subset to second set and second set is subset to first set, then those two sets are equal. Therefore a minus b is equals to a intersection b dash. Therefore a minus b is equals to a intersection b dash. In this way you may prove the second, third and all these results. I will prove one more result and I will give all this as your practice. Now I am taking third result to prove. See what it says. A minus b is equals to b dash minus a dash. Similarly, I will take one element in the first set, then I will prove the same element will be in the second set also. Let x belongs to a minus b. All of you know that x belongs to a minus b means it will be in a only and not in b. Why? Because you are removing b. Therefore I will write it as x belongs to a and x does not belongs to b. If x is in a, then it will not be in a dash. A and a dash are disjoint sets. They will have no common elements in them. Therefore I will write x does not belongs to a dash and x belongs to b dash. If x is in b, automatically it will not be in b dash. Therefore I will write x belongs to b dash first and x does not belongs to a dash. See, the element x is in b dash and not in a dash means how can you write it? Therefore x belongs to b dash minus a dash. It is not in a dash, therefore I am removing by putting minus. Then x belongs to b dash minus a dash. I am taking the element in the first set and proving that it is in the second set. Therefore first set is subset or equals to second set. Therefore a minus b is subset or equals to b dash minus a dash. You may take it as equation number 1. And similarly I will take one element in the second set and prove that that will be in the first set also. Let x belongs to b dash minus a dash. That implies to x belongs to b dash and x does not belongs to a dash. Why? Because minus means you are removing, that means we will not take the elements of a dash into consideration. That implies to if x is in b dash, it will not be in b. I will write it as x does not belongs to b, and also if x is not in a dash, it will be in a. I will write it as x belongs to a. Therefore I will write x belongs to a first and then x does not belongs to b second. See, x is not in b and in a. How can I write it? X belongs to a minus b. That means I am not taking the elements of b, means we have to write minus. I have taken one element called x which is in b dash minus a dash and proving that it is in a minus b. Therefore the first set will become subset or equals to second set. Therefore b dash minus a dash is subset or equals to a minus b. Let it be equation number 2. From equation 1 and 2 you observe that first set is subset or equals to second set and second set is also subset or equals to first set. Therefore basing on the law of equality of two sets, first set will become equals to second set. Therefore a minus b is equals to b dash minus a dash. In this way you may prove other results also. A minus b intersection b. See, a minus b means we are removing the set b. That means there are no elements belongs to b and intersection b. That means this is nothing but the elements of a only. And if you are doing intersection with b means you will not find any common elements between only a and b. Therefore the set is null set, means it will not contain any elements in it. And we proved this also. And if you come to the fourth result, if a is subset or equals to b, then b dash is subset or equals to a dash. B dash and a dash are complement sets of a and b. A dash means that is the set when you remove a from complement, that means universal set. You will get a dash if you remove the set a from universal set, and B dash is the set which is obtained when you remove the elements of B from the universal set. And coming to the fifth one, it's very important also, A union B. You know what is meant by A union B. A union B is a set which contains the elements of either A or B or both. Elements of either A means A minus B, that means only A, and B minus A, only B, and A intersection B, the elements of both A and B. So A union B is nothing but combination of elements of only A, comma, only B and both A and B. Coming to the sixth results, A minus B. A minus B means you are removing B, that means you are having the elements of only A. A minus only A, that is nothing but A intersection B. A minus only A, you are removing the elements of only A, that means you are having the elements which are common to both A and B. Therefore A intersection B means elements of both A and B. Coming to the seventh results, A minus B is equals to B minus A. Suppose actually you know that A minus B is generally not equals to B minus A. If A minus B is becoming equal to B minus A, definitely they will become equal sets, otherwise it is not possible. And coming to eighth one, if A union B is equals to A intersection B, automatically A union B generally is not equals to A intersection B. If they are becoming equal, that means A automatically equals to B. Suppose if A is equals to 1, 2, 3, then B is equals to 1, 2, 3, then only A union B will become equals to A intersection B. Automatically the sets A and B will become equal. Next important topic on sets is very simple. See, that is cardinal number of a set. The cardinal number of a finite set, it should be finite, is the number of distinct elements in it. Very simple, it should be finite and the number of elements in it is said to be cardinal number of a set. Suppose if you take a set A, then its cardinal number is represented as number of A. That is nothing but counting the elements of the set A. It should be finite. Suppose I am taking A as x, y, z. How many elements are in this set? 1, 2, 3. It's very clear. Therefore, you will write number of A is equals to 3. And I am also taking another set. For example, B is equals to null set. Null set means it will not contain any elements in it. You may write it as number of B is equals to 0. Basing on the cardinal number of sets, you have some important results. The first result is number of A union B. That means the number of elements in the set A union B is calculated as number of A plus number of B minus number of A intersection B. You have to write number of elements of A and B, and you have to remove which are both in A and B. You should not take an element twice. If it is in A and B, that should be written only once. Therefore, we are removing the elements which are common to both A and B, that is written as number of A intersection B. That's very clear. And coming to the second result, that is the same number of A union B. That means number of elements in A union B will become number of A plus number of B if A and B are disjoint. Disjoint means the two sets will not have any common elements in it. If they don't have any common element, number of A intersection B will become 0. And I am writing the same, i.e. number of A intersection B is equals to 0. It is not necessary to write this part. Therefore it will become only number of A plus number of B. That means you have to understand that A and B are disjoint sets. Coming to the third one, number of A dash. A dash is the complement of set A. That means you are removing the set A from universal set. So I am writing number of elements in the universal set minus number of elements in the set A. That will become number of elements in A dash. Coming to D, number of A dash union B dash. You know, A dash union B dash may be written as A intersection B whole dash. This is De Morgan law. Means A intersection B dash means mu minus A intersection B. Therefore, number of elements in the universal set minus number of elements in both A and B. Coming to the E, which is same as D, number of A dash intersection B dash. You know again De Morgan law, A dash intersection B dash is written as A union B whole dash. Dash means complement. You have to remove it from universal set. Therefore, number of U, which is universal set, minus number of A union B. Okay. Coming to F, number of A minus B. A minus B, you know, you are removing the set B from A. That means you should not take any elements which are common to A and B. I am writing the same number of A, means elements of A minus which are common to both A and B. I am removing which are common to both A and B, and it is written as number of A intersection B. Finally, you have number of A union B union C. Means I am taking three sets A, B and C, which are finite sets. Then you will calculate the number of elements in that set as number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of C intersection A. But finally you have to write plus number of A intersection B intersection C. Finally you have an important result, that is number of A1 union, A2 union, A3 union and so on union AN. These sets A1, A2, A3 and so on are disjoint sets. If they are disjoints, means they don't have any common elements in them, you may write the number of elements in individual sets and you may add those elements, those numbers. That means number of A1 plus number of A2 plus number of A3 plus and so on number of AN. You come across this here, that is number of A union B. They don't have any common elements in them. Therefore, you have to count elements in A and elements in B and add them. You will get number of elements in A union B.